Hi, I'm Mr. Huber, and in this video I would like to talk about 12b. Well, in the right-angled triangle ABC are given, the height and the length of the angle bisector W gamma. Well, you have to make a large drawing here, otherwise it will be very difficult to understand. Well, it's very special. We're supposed to work out A and B, and we know we're only allowed to use right-angled triangles. So what's the first thing we can work out? The first thing we could work out is this angle here. Well, let's label that one delta. Well, here in your handbook you find many Greek letters, and I'm going to use delta. Later on I'm going to use epsilon, and then after that theta. Why not? Okay. Well, delta. That's very easy because you have a right-angled triangle. This one. That's a right-angled triangle. And we know the adjacent and the hypotenuse. This is the adjacent side and this is the hypotenuse. Well, that calls for a cosine. Cosine of delta is adjacent, 25 over the hypotenuse, which is 32. Okay, well, the end goal is to work out A and B, but we start with what we can do. Okay, delta. So in order to work out delta, we need the inverse cosine, which is arc cosine here, 25 over 32. Okay, 25 arc cosine 25 over 32. That's 38.62. So delta is approximately equal to 38.62. Well, let's store that as A, or A. Okay, this is A. Good. Now we know what this angle is. Let's label that one epsilon. Why do we know that? Because this is the angle bisector of the 90-degree angle. So this is 45 and this is 45. So it's easy to work out. So epsilon is in fact 45 degrees. So the whole angle minus delta. So 45 minus, recall A. So that's 6.38. Epsilon is approximately 6.38 degrees. And we know this angle. Let's label that one theta. Because this angle is in fact 45 degrees plus delta. So let's work that one out. Delta is 45 degrees plus delta. Well, that's 45 plus, recall A. That's 83. Theta is 83.62. Now, why is that important? Because look, now you have two right-angled triangles. You have this one in blue. That's a right-angled triangle. You know epsilon and you know the height. So it's easy to work out B. And you have another right-angled triangle, the red one. Now you know theta and you know the height, so you can work out A. So let's do that. It's very easy. Here in the blue one, it's cosine epsilon is adjacent over hypotenuse. Adjacent 25 over the hypotenuse B times B. B times cosine epsilon is 25. B divided by 25. B is 25 divided by cosine epsilon. So I'm going to use this value for epsilon. Let me just rewrite that, 25 over cosine 6.38. I could have stored this value, so when I did it for myself, I used the exact value, so it's going to be 25.16 units of length. Now you do the same thing, the exact same thing for A, because cosine theta is adjacent over hypotenuse. So adjacent is the height, 25, over the hypotenuse. You multiply by A times cosine theta, 25. Then you divide by cosine theta. Again, I'm using the exact values. So A is going to be 25. I'm just writing this value, but I'm using for my calculation the exact value, 83.62 degrees. And when I do this, I'm going to get A is equal to 225.15 units of length. But look, if I had used the rounded value, let's just have a look at that, okay? Let's use the rounded value, 25 divided by cosine 83.62. Yeah. I would have got 224.98. That would have been quite a difference, okay? That's why I use unrounded values, but I'm not going to store them each and every time here in order to show you, because that just puzzles you. But well, I pre-calculated everything, and I know this is the value when you use the stored value. But I've shown you many times how to store values now. So you should have stored this value and this value because you're going to use them later on. Well, in an exam, I will probably give you still all the marks if you use the rounded values. But well, in order to practice, you should know how to use the stored values. But see, it makes quite a difference. This is the value we want, and this would have been the value if you had used the rounded value here. Quick recap, we were given the height and the angle bisector of gamma. We worked out this angle here, delta. Then we were able to work out epsilon in this right triangle, and we were able to work out delta in this right triangle. Well, you might ask, well, how can I know that? Well, oftentimes it's difficult to see what you want to do right away, okay? So you can start off by something you know how to do, okay? Like working out delta, working in this right triangle, in the first one, okay? You could start off like that. And then eventually by doing that, you see what's going to happen. It's always difficult to see at the start what you have to do in order to achieve, or in order to be able to work out your end goal, okay? This comes with experience, and I'm showing you one of many solutions. So I hope everything was clear. See you in the next one.